So here we have one more problem on motion with a uniform acceleration in the horizontal direction. On turning a corner, a motorist is moving with a 15 meter per second, means on a particular curve a motorist is moving with a velocity of 15 meter per second. This is what is a car which is going to move along a curve. What is mentioned further? He finds a child on the road at 50 meter ahead. So when he is at a point O with velocity 15 meter per second, at a distance of 50 meter he watches a child who is trying to cross this particular road. Is it okay? So distance between the car and the child is equal to 50 meter. He instantly applied the brakes so as to stop the car within 10 meter away from the child. Is it okay? So here at point O he applied the brakes and exactly 10 meter before he is going to come at rest. Is that okay? So this is how we have to understand this particular problem. In this problem we got to find out retardation of the motion and time required to stop the car. So here initially motorist is at point A and child is at point B. So initial velocity is equal to 15 meter per second. Final velocity is equal to 0 because the car has to come at rest. So there is a retardation. So using a kinematic equation of motion, v square is equal to u square plus 2as, substitute the various required and given value. Simplifying it, I got a value of acceleration is equal to minus 2.81 meter per second square. So this is how we have to find out the value of retardation so that the car will stop within the reasonable distance away from the child. Now the second thing which is required, time required to stop a car. We know Vc is equal to Vb plus At. So V equal to U plus At. We know finally the car has to come at rest. So V is equal to 0. Initial velocity is given 15 meter per second and acceleration is found out minus 2.81. So we can find out the value of t. So t is equal to 5.338 second. So we have found out the value of retardation of the car and also we have found out the time required to stop the car 10 meter ahead before that particular child. So this is how we have to analyze this particular problem. So without wasting much of the time, we will move to the next problem. A driver of a car running on a highway wants to stop at a hotel for a breakfast. So here is a car. A driver is driving the car. He sees a hotel some distance ahead on the highway and applies the brake. He covers a distance of 36 meter in first 2 seconds and 51 meter in next 3 seconds. Is it okay? So in first 2 seconds he has already, before watching the hotel, in 2 seconds he has crossed 36 meter and in next 3 seconds he will be moving 51 meter ahead. We got to find out the distance covered by a car in subsequent 4 seconds and the total distance travelled by the car before the car stops at the hotel. Is it okay? So let us consider the first path of motion, that is A and B. So distance is equal to 36 meter and t is equal to 2 seconds. So s is equal to ut plus half at square. Substitute the appropriate values. You have this first equation, 18 is equal to u plus a. Got it? Now once again we have given data that from next 3 seconds it will be moving to 51 meter. Is it okay? Now what I will do, I will consider the second path where the total time will be 5 seconds and total distance will be 36 plus 51. So consider the motion AC. So s is equal to 36 plus 51 is equal to 87 and total time is equal to 2 plus 3 is equal to 5 seconds. Is it okay? Now here we have s is equal to ut plus half at square. Substitute the value of s and t and simplify it, you will be getting equation number 2. Is it okay? Now you have equation number 1 and equation number 2 which has two unknowns u and a. we can perform any mathematical operator on this and find out the value of equation u and a. Is it okay? So we can solve equation 1 and 2, which gives you the value of a equal to minus 0.4 meter per second square and initial velocity is equal to 18.4 meter per second. Is that okay? So this is a partial solution of the problem. Further, what was required to find out? Distance covered by the car in subsequent 4 seconds. In next 4 seconds, how much will be the distance traveled? And second thing which we have to find out is total distance traveled by the car before car stops at the hotel. So what is been given, I will compile that. So in next consecutive 4 seconds, it will travel a distance of total s meter from the initial one a to d. Total distance traveled was asked, it was equal to s meter. Is it okay? Now total time is given 2 plus 3 plus 4 is equal to 9 seconds, means from a to d total time is equal to 9 seconds. So s is equal to ut plus half at square. You have already found out the value of u, a and t also. Substitute the values. So total distance traveled in next 4 seconds is equal to 149.4 meter from a to d. Is it okay? So this is what is the total displacement from a to d. Now again the car has to come to rest near the hotel. Is it okay? So we got to find out the total distance covered from a to e. So that will be s total from a to e. Is it okay? This is the required thing in the next part of this particular problem. So in order to find out the total distance covered from a to e, we know v square is equal to u square plus 2a and s total. As car is going to stop at hotel, therefore final velocity equal to 0. And initial velocity already we have found out, u is equal to 18.4 and acceleration also we have found out. So substitute the appropriate values, simplify it, you will be able to find out the total distance from a to e, that is equal to 423.2 meter. So this is the way how we have solved this particular problem part by part. So first part was a to b, second part was b to c, next was c to d, and the last was d to e, and for each and every path we have found out the total distance traveled. Is it okay? So 36 and 51 was already given. Total distance traveled from a to d equal to 149 we have found out, and also we have found out the whole total distance from point A to the hotel point E. So this is how we have to analyze the problems by understanding the problem very thoroughly. Let's move ahead and talk about the next problem. There are two cars moving in the same direction and they are apart from each other by a distance of 150 meter. Car A is being ahead of B. So we have two cars which are at a distance of 150 meter apart. Car A is ahead of B. Now at this instant velocity of A equal to 3 meter per second and constant acceleration is 1.2 meter per second square, while velocity of B equal to 30 meter per second and uniform retardation equal to 0.6 meter per second square. So whatever is given I have shown along with the figure of the cars. Is it okay? Now we have to find out how many time does these car do cross each other, means they will be overtaking each other. So let us find out when and where they cross with respect to A. Is it okay? So with respect to A means with respect to A car. So let this be the point where these two cars will be crossing each other. Is it okay? Which is at a distance of D, which was measured from point A. You can see here from point A car, the distance travelled where they will overtake each other is equal to D, right? So distance traveled by B car will be equal to what? 150 plus D, and distance traveled by A car will be equal to what? That will be equal to D, right? So after understanding the problem thoroughly, consider the time of journey to meet one point so that they will cross and overtake. Let that time be equal to T. For car B, SB is equal to UT plus half AT square. The total displacement by car B will be equal to 150 plus D. Time taken will be equal to T, and retardation is already given for this problem. AB is equal to minus 0.6 meter per second square. So I have substituted the value. I got equation number 1. Now for car A, how much is the displacement? SA equal to D. So SA is equal to UT plus half AT square. Substitute the appropriate values. So you got equation number 2. Now both these equations are having certain unknowns, that is D and T. So by solving these two equations, you will be able to find out the value of displacement D, where both car will be meeting, and time when they shall be meeting each other. As their left hand sides are same, so I am just equating them. I will simplify them. So I got T equal to 7.36 and T equal to 22.64 second. As this being a quadratic equation, I will be getting two values of T. Unfortunately, both are positive. Means at T equal to 7.36 second, first time there will be overtaking, and after T equal to 22.64 second, there will be another overtaking at certain distance, right? So we have two times, so we got to know two displacement at T, displacement at T equal to 7.36 and displacement at T equal to 22.64. So what I have to do is, I will substitute the value 1 by 1 in equation number 1 or 2, whatever it is. Is it okay? So here I have taken equation number this one 2 and I have substituted the value. You can substitute anywhere in either equation number 1 or 2, you will be getting the same values. So at T equal to 7.36, I got D equal to 54.58 meter, and at T equal to 22.64 second, I got D equal to 375.6 meter. So this is what I was talking about. At 7.36 time, first overtaking will take, and after 22.64 second overtaking will be taking, and also we have found out the distances at which this overtaking is going to take place. So at 54.58 meter and at 375.6 meter, it is going to, they are going to overtake each other. Is that okay? So this is what is the thing we have to understand. So we got D equal to, that is the displacement of car A. Now we got to find out the displacement of car B. Is it okay? So distance travelled by B will be equal to what? SB is equal to 150 plus D. This is 150 plus D. 150 plus D. Substitute the value of D. So we are getting 150 plus 54.8 equal to 204.8 meter, and another value of D, that is 375.6, I have to substitute, so that that equation or that SB, distance travelled by car B, will be equal to 525.6 meter. So this is how we have found out the distance travelled by the car A as well as B. Also we have found out the time at which the overtaking is going to take place. Here we concluded the overtaking is going to take place twice. First at T equal to 7.36 at a distance of 54.58, and second instant it will be equal to T 22.64 second at a distance of 375.6 meter. Is it okay? And also we have found out the distance travelled by the car B at both the times. So with this, I shall conclude with this particular problem. I hope you have understood each and every problem which we have seen by now. Just to make a concluding remark on this particular article, read the statements very carefully, try to understand the statements very carefully, try to grasp the thing what are given in that particular problem, and make it as a habit to enumerate under the heading of given things. So find out the given things, then try to understand what is required out of this particular problem. Once the objective and object is clear in front of you, you will be able to select appropriate formula at a proper place. And after selecting appropriate formula, we just have to simplify by putting the known value and finding out the unknown value out of that particular problem. And this way, by having this particular philosophy of solving the problem, you will be definitely solving any sort of the problem under this motion with uniform acceleration. So with this, I shall be concluding for today. I am signing off. Thank you very much and for having the patient listening. Thank you.